Hey everyone, this is Mrs. Richard. Today we're going to combine some older material that we already know with some new material and put it together. So we're going to solve quadratics by factoring and graphing. We know how to graph and we know how to factor, now we're just going to solve. We're also going to be using something called the zero product property. To solve quadratic equations like these, there's lots of different methods you can use. These are the 5 major ones. Today we're going to focus on factoring and graphing. So factors versus roots. Factors are x plus 2, x plus 3, x minus 7, x minus 10, and the zeros or roots or x-intercepts or solutions that go along with them are x equals negative 2, x equals negative 3, x equals 7, and x equals 10. Zeros, roots, x-intercepts, and solutions are all words for the same thing. So what do you notice? You might notice that all of these, the signs are opposite. That's going to be a theme here today. A factor times a factor is a product. We've learned that. So for example, 6 times 7 is 42. 6 and 7 are our factors, and 42 is our product. Similarly, with algebra, we can say x minus 1 times x plus 2 is x squared plus x minus 2. These two are factors, two things that multiply together to get our product. The zero product property. If I said 8 times something is 0, what is the only possible number that can make this statement true? It has to be 0. Similarly, if I said something times 8 equals 0, the only number that works and makes this equation true is 0. The zero product property states to get a product of 0, one of the factors must be equal to 0. So if x times y is 0, then either x equals 0 or y equals 0. That is the only possible way for that equation to be true. At least one of them have to be 0. If we have this right here, we have x minus 1 times x plus 5 equals 0. Remember, this is the factored form. This means that we can say x minus 1 equals 0, or the other factor, x plus 5 equals 0. If we solve for x, we add 1 to both sides, we get x equals 1. If we subtract 5 from both sides, we get x equals negative 5. We can type x minus 1 times x plus 5 in Desmos, and also y equals 0 in Desmos, and we can check by graphing. We have negative 5, 0, and 1, 0 as solutions, because those are the x-intercepts, zeros, roots, or solutions. It's what makes the equation true, where that graph hits y equals 0. If we have something like this, we could take 3x plus 1 equals 0, or 2x plus 5 equals 0. If we solve the equation for x, we subtract 1 from both sides and get 3x equals negative 1. We can divide both sides by 3, and we get x equals negative 1/3. Similarly, we can subtract 5 from both sides and get 2x equals negative 5, divide both sides by 2, and get x equals negative 5/2. These are our two solutions. If we type this into Desmos, the left side in one cell and y equals 0 on the other side, the right side, we get negative 2.5, which is the same as negative 5/2, and negative 0.333 repeating, which is the same as negative 1/3. Once again, we can set these equal to 0, 2x minus 3 equals 0, and 2x plus 8 equals 0. Add 3 to both sides, we get 2x equals 3. Divide both sides by 2, we get x equals 3/2. Subtract 8 from both sides, we get 2x equals negative 8. Divide both sides by 2, we get x equals negative 4. These are our two solutions. Once again, we can check graphically, and we get negative 4 and 1.5. 1.5 is the same as 3/2. If we solve this by factoring, x squared minus 7x equals 0, I can say x is my GCF. X times what is x squared? Well, that's x. X times what is negative 7x minus 7. That means that if we solve, we have the one factor is x equals 0, or x minus 7 could be 0. The number that will make x minus 7 equal to 0 If we add both sides 7, then we have x equals 7. Those would be our two solutions. If we plug them into Desmos, x squared minus 7x and y equals 0, we get 0, 0, and 7, 0. So x equals 0 and 7 we have checked by graphing. Lastly, we can take this equation in standard form, 2x squared minus 5x minus 12, head times butt is negative 24. In order to get a negative number with multiplication, we can take a positive times a negative. If we list our factors of negative 24, we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. We want to add to get the gut, which is negative 5. The one pair that will give me negative 5, if we make it positive 3 and negative 8, is 3 and 8. If we break up that negative 5x, remember it doesn't matter if you put 3x minus 3x minus 8x, or negative 8x plus 3x. Breaking it up into two parts, 2x squared and 3x share an x. And we know that 2x plus 3 is left over. We want 2x plus 3 in our next set of parentheses. So negative 8 and negative 12 share a negative 4 in common. So we also have 2x plus 3 left over. And you can redistribute the negative 4 and check that you do get negative 8x minus 12. That means one of our factors is 2x plus 3, and one is x minus 4. That's our factored form. If we continue, and notice the only difference from today and last week was that we set it equal to 0, we know 2x plus 3 could be 0, or x minus 4 could be 0. Subtracting 3, dividing by 2, we have negative 3 halves. Adding 4 to both sides, we have x equals 4. We can once again check this by graphing, and we get negative 1.5 and 4. If you have any questions, ask your teacher. Now, remember, you can begin your Schoology and your Cami practice. It's 2-part for today. Good luck!